So in today's lesson, we'll learn about relations. In the previous lecture, we had already seen sets. So we had seen set theory, operations on sets. And in the last lesson, we had seen the Cartesian products of sets. So we will be carrying that definition further because the relation is defined on the basis of the Cartesian product of two sets. So let us see what we mean by relations. So let A and B be two non-empty sets, then any subset R, we have already seen what is a subset, then any subset R of the Cartesian product A cross B is called a relation. And how we used to call it? We call it a relation from A to B because it's the subset of A cross B. So it will be called as a relation from A to B, and it is denoted by capital R. And the definition we can see here, capital R basically is a set of ordered pairs x comma y, where x comes from set A and y comes from set B, such that x is related to y with some definition. Okay, so where this xry denotes that x is related to y. Let me just repeat this definition. What is a relation? Relation, let A and B two non-empty sets, then any subset R of their Cartesian product A cross B is called a relation from set A to set B, and it is denoted by R. So the symbolical definition of R is that R is a subset which contains ordered pairs x comma y, where x comes from A and y comes from B, such that x is related to y. Now let us understand this with the help of an example. In the previous lecture, we had already discussed what is the Cartesian product. So let me show you the example number 1. Let there is a set A with elements 1, 2 and 5. And there is another set, let's say B, with elements 2 and 4. Right. Before we define the relation, let us calculate the Cartesian product, which is A cross B. So what is A cross B? It's the ordered pair like 1 comma 2, then 1 comma 4 and so on. So we'll take 1 comma 2 is the first ordered pair, 1 comma 4 will be the second ordered pair, 2 comma 2 will be the third ordered pair, then 2 comma 4, then we have 5 comma 2, and then we have 5 comma 4. This is the Cartesian product which is containing all the ordered pairs here, and this Cartesian product is from set A to set B. Now a relation R is defined here. R, let us see what is R. R is defined as the ordered pair x comma y such that x comes from A and y comes from B, and the relation in between that x is less than y. So there is a specific condition that which ordered pairs are to be considered. Only those ordered pairs are to be considered where x is less than y. That means the element which is coming from A has to be less than the element coming from B. Now let us see which ordered pairs satisfy this condition. Let's say this is the first ordered pair. Okay, what is x here? X is 1. What is y here? Y is 2. So is it in this case x is less than 2. So this ordered pair will be included. Next is 1 comma 4, x is 1, y is 4, x is less than 4, this will also be included. Here x is 2 and y is also 2, but here x is not less than y. That means both are equal. So this ordered pair is not according to this definition, hence it will not be included. The next one is this one where 2 is x, 4 is y, again x is less than y, so this will be included. In this, x is 5 and y is 2, and we can see that 5 is not less than 2, so this will not be included into the relation. And lastly, this is x and this is y. Here also 5 is not less than 4, so this ordered pair will not be included. So we will be able to form this R, and which ordered pairs are included? 1 comma 2, then we have 1 comma 4, then we have 2 comma 4. So only these ordered pairs are included, and this is the relation which we were talking about here. R is having all ordered pairs where x is coming from A, y is coming from B, and x is less than y. And now we can also see that this is basically R is a subset of A cross B because it is containing few elements from A cross B. So it is the subset of A cross B. Example number 2. Okay, let A is a set with elements 1, 2, 3, 4, 5, and 6. And then there is another set 4. It's defined, which is with the elements 2, 8, 12, 10. Okay. And now a relation R is defined such that x comma y, definitely where x will come from A and y will come from set B, such that x is equal to y upon 2. Okay, so this is the basic relation, that x is equal to y upon 2. Okay, now again we all know that R is a subset of A cross B. What we can do is, first we can from A cross B, and then from that A cross B we can select the ordered pairs which are fulfilling this condition. But this A cross B will have a lot of elements, so I'm not forming this A cross B, and I'm directly writing this R by applying this particular condition, that x is less than x is equal to y upon 2. So let me see which ordered pair I can have. So this is 1, and here we have 2. So this is x is 1 and y is 2. So this is 1 comma 2. Is it fulfilling the condition? X is y upon 2. Here x is 1 and y is 2. So 2 upon 2, which is 1 is equal to 1. So it is fulfilling the condition. So 1 comma 2 will be there, and we will not be having any other ordered pair with 1, because 1 comma 8, 1 comma 12 and 1 comma 10 will not fulfill this condition. Okay, next let me go to this second element, which is 2. So I will not be able to pair this 2 with any other element, right? Because I can say that this condition can also be written as 2x is equal to y. So 2 to the 4, and there is no 4 element, so 2 will not be related with anyone. Then 3, so we will have 3 to the 6, no element is here. Then we'll have 4 to the 8, so we have this element 8 here. So the next will be 4 comma 8 ordered pair will be here, right? Next is 5 to the 10, so this will be 5 comma 10 will be here. And the last one 6 to the 12, so this will be 6 comma 12 here. So only these pairs, ordered pairs, will be here because these are fulfilling the condition. So R is our given relation.